Discover the power of LFI Hunter, a cutting-edge command line tool designed to test and exploit local file inclusion vulnerabilities. With features like authenticated scanning, aggressive mode, LFI fuzzing mode, read file option, parameter fuzzing, reverse shell setup, and more, LFI Hunter is the ultimate companion for ethical hackers and security researchers. Unlock insights into web application security and take control of vulnerabilities in a controlled, professional manner. Available now on GitHub at Jack11 LFI_Hunter. Let's start with aggressive in LFI Hunter. To begin, you need to add a session cookie using the C flag. If the target web application accepts the cookie, you can store it in a file and provide its path. In case no cookie is specified, the tool will default to none. For authentication, provide the vulnerable URL using the UV flag, the login URL with blue. The HTML username field with auth, and the HTML password field with PF. You also need to supply a valid username and password using the UN P flags, respectively. If your username or password contains special characters, it might cause errors in the terminal. In such cases, save credentials in a file and specify path. When using aggressive mode, simply provide the vulnerable URL and session cookie. This mode sends different payloads, such as various path traversal strings opening parenthesis / or URL encoded paths. It compares the length of the response pages. If the page length changes and increases, it indicates the link might be vulnerable. Aggressive mode will then prioritize and analyze the URLs that yield the most data. Authentication can be combined with various modes, including aggressive mode, read file mode, and fuzzing mode user, auth flag. When using read file mode, always start by providing the auth flag for authentication. It's highly recommended to use this mode after discovering the vulnerable URL through aggressive mode. Why? Aggressive mode highlights URLs that are leaking data, allowing you to pinpoint exactly which files can be read. To read a specific file, use the R flag followed by the file's path. You can operate in either authenticated or unauthenticated modes. When retrieving data, the tool automatically creates a folder named FileStore. Inside FileStore, it generates another folder using the name of the target web application. Within this folder, files containing the leaked data from the URLs are stored for your analysis. This approach ensures that you have an organized and clear view of the extracted data from vulnerable links. Read file mode is your next logical step after identifying vulnerabilities with aggressive mode. To enable brute force mode, use the Z flag. This mode works by sending one payload after another to the target. If any payload retrieves additional data, the process stops, and the leaked content is saved for analysis. Brute force mode supports both authenticated and unauthenticated operations. For authenticated access, include the required flags like auth. By default, the tool uses its internal word list for payload generation. However, if you prefer to use your own custom word list, simply specify it with the F flag followed by the path to your word list file. This flexibility allows you to fine-tune your testing approach, whether you're using the default setup or tailoring it with your own payloads. Brute force mode is a powerful option for discovering vulnerabilities and extracting critical data from your target. Let's reverse shell with LFI Hunter, including SSH log poisoning for remote code execution (RC). The tool includes an automatic netcat listener, making the process straightforward. To establish a reverse shell, start by identifying a file you can read, such as access.log, a session cookie, or an SSH log file. These files can be injected with PHP code to execute commands remotely. When it comes to SSH log poisoning, the tool simplifies the process using Python's Paramiko library. Instead of relying on manual terminal injection, which can be patched or restricted, LFI Hunter uses automated SSH handling in Python to perform the injection securely and efficiently. Begin with aggressive mode to determine which files are accessible. Once you've identified a target file, such as an SSH log, you can inject it with the required payload to enable RC. The reverse shell feature works seamlessly with both read file mode and brute force mode. To enable it, use the S flag followed by your listener IP address. By default, the tool sets up a listener on port 7777. If you need a specific port, use the port flag followed by your desired port number. For example, with your listener ready and the target file confirmed vulnerable, LFI Hunter will establish a connection, enabling you to interact directly with the target system. This functionality, combined with automated SSH log poisoning, makes the tool a powerful asset for testing systems. Now, let's web shell option in LFI Hunter. This feature captures web responses and saves them into files. By comparing the initial response with the modified one, it detects any changes, which may indicate successful command execution. The process operates entirely over the HTTP protocol, eliminating the need for direct connections or a dedicated port. It works seamlessly with PHP code injected into log files, session cookies, SSH logs, or similar files. This functionality allows you to remotely execute commands through the web application in real time. The web shell option mimics the behavior of using a web shell from a browser interface, offering an interactive and efficient way to test for vulnerabilities. After performing an aggressive scan, you might find that you can read a session cookie. Using the web shell option, you can inject PHP code into the cookie and achieve remote code execution. We tested this feature with Hack the Box's LFI Labs, and it proved to be an effective way to gain command execution in a controlled testing environment. With this approach, you can streamline your testing workflow and gain real-time insights into the target application's behavior. Let's dive deeper into the PHP filter encode option in LFI Hunter. This powerful feature is designed to extract and decode sensitive information from vulnerable web applications. It's particularly useful for reading source code from files like database configuration files, PHP settings, or critical PHP pages such as index.php. Using the B flag, the tool automates the entire process by applying the PHP convert.base6 for encode. This filter retrieves the file's content in a base64 encoded format, bypassing certain restrictions imposed by the server. It can also be combined with other modes. Aggressive mode to quickly identify files worth decoding. Read file mode to directly specify and read target files. Brute force mode to test various payloads and pinpoint vulnerabilities. Once the data is decoded, LFI Hunter automatically saves it into a designated folder, ensuring all extracted and processed information is securely stored and easy to access. The B option is invaluable for ethical hackers and researchers. With LFI Hunter, the entire process is streamlined, saving time while providing actionable insights. Whether you're working with configuration files, debugging PHP source code, or examining hidden files, this feature ensures you can decode, analyze, and store the information efficiently for your security assessments. Now, let's option in LFI Hunter. This feature helps you discover hidden parameters or directories within a URL. To use it, include the FP flag followed by the URL you want to test. Replace the part of the URL you want to fuzz with the word parami. For example, if you're looking for a PHP file, replace the file name with parami.php. If you're searching for query, the tool will automatically replace parami with words from its word list to identify parameters or directories that respond with meaningful data. Word list management. By default, LFI Hunter uses its internal word list for fuzzing. If you want to use your custom word list, provide its path using the PL flag, followed by the file path. Response filtering. The tool filters results based on response codes and response lengths. You can specify response codes to filter using the S flag, followed by the desired status code, such as S200 or S301. By default, it considers the most common codes, like 200, 301, 302, 404, and 500. Customizing your word list and filters. Parameter fuzzing provides a thorough and efficient way to analyze web application behavior. This option is highly versatile and can be used to identify critical parameters, trees that might be vulnerable to exploitation. Now, let's look in LFI Hunter. This feature simplifies the process of running long and complex commands by automatically generating a configuration file for each command you execute. Instead of typing out the full set of arguments each time, you can save time by reusing the configuration file. For example, if you're working with an authentication command that includes multiple arguments such as a login URL, username, password, and cookies, the tool will create a .ini file containing all these details. The configuration file is named based on your target. If the target is an IP address, like 192.156.39.2, the config file will be named 192.156.39.2.ini. If the target is a domain, like http://www.anything.com, the config file will be named anything.ini. One of the most useful features of the config option is the ability to overwrite specific options in the file. For example, if you want to update the cookie path without retyping the entire command, you can simply run config anything.ini per path to new_cookie. This flexibility allows you to modify specific settings on the fly while retaining the rest of your saved options. The config option streamlines your workflow, saves time, and reduces the chances of errors when working with long or repetitive commands. It's especially valuable for automating tests, switching between targets, and customizing configurations efficiently. Lastly, let's in LFI Hunter. The tool includes a detailed manual page to provide users with comprehensive guidance on each command and how to use it effectively. To access the man page, simply use the man flag. This command displays all the essential information about the tool, including descriptions of each option, usage examples, and explanations of its features. It's an invaluable resource for both new and experienced users, ensuring you can fully utilize LFI Hunter's capabilities. Whether you're exploring authentication modes, parameter fuzzing, or reverse shells, the man page has you covered with step-by-step details and practical examples to guide you through your tasks. Whenever you need clarification or a quick reference, the man command is your go-to tool for understanding and mastering LFI Hunter. In conclusion, and powerful command line tool designed to uncover and exploit local file inclusion vulnerabilities in web applications. LFI Hunter's combination of powerful features and ease of use makes it an invaluable tool for ethical hackers and security researchers. Thank you for exploring LFI Hunter with us. Use it responsibly, and always respect the boundaries of ethical hacking.